check this video out later on. Go back and have some questions. So each one of these atoms on the periodic table has different properties and a different makeup. And today we're going to learn a little bit about what goes into building an atom. What are all the different pieces that we need? And how can we figure out how many of each piece is there? So this is sort of a basic cartoon drawing of an atom. Obviously, they don't exactly look like this, mostly because A, we can't say for sure exactly what they look like because they're so incredibly, amazingly tiny and small. And also these outside parts and inside parts are kind of constantly moving around and shifting around. But an atom is the smallest unit of matter. It is the teeniest, tiniest particle building block that all the other matter in the universe is made out of. So all of the solids, all the liquids, and all the gases on Earth and the galaxy and the universe, they are all built out of atoms. So there are three major parts of the atom that we are going to be going over today. We've got the protons, we've got the neutrons, and we've got the electrons. So today we're going to be talking about what are the difference between these three particles and how many of them go into different types of atoms. So even just by looking at this picture on the screen here, you can see that there's kind of two different areas of an atom, right? We've got this inner kind of middle area where the protons, which are marked in red on this picture, and the neutrons, which are marked in blue, are together. So they're kind of clumped up in this middle area right here. And then the electrons are on the outside part, kind of zooming around the outside of the atom. So just like the moon orbits around the Earth and the Earth orbits around the sun, these electrons orbit around the middle part of the atom. So this middle part of the atom actually gets its own name. It is called the nucleus. So the nucleus is like the center of the atom. It's the middle section of our atom. Most of the atom's mass, so the actual weight of the atom, like 99.999% of the mass of an atom comes from the nucleus right here. And like I was saying earlier, you can tell that we have our two different particles clumped up in here, our protons and our neutrons. So the protons and the neutrons are clumped up in the middle here, and the nucleus all clumped up together. And then our electrons, our third type of particle, are orbiting around the outside. They're zooming around the outside part of the atom. So nucleus for like the center, the middle area right in here. So what goes into building up our nucleus? Well, we have our protons in the nucleus, and protons are important for an atom because they have a positive charge associated with them. So in terms of electric charges, we have negative charges and we have positive charges. Protons are positively charged. So if you imagine they're charged, it would be like a little plus hanging out down here. So this one is fairly easy to remember for me because positive protons both start with P. So our protons are positive, and they're hanging out in the nucleus right here. All right. So our positive protons are hanging out down here in our nucleus. The other guy that's here in the nucleus as well are the neutrons. So the neutrons are also in the nucleus, this middle section right here. And the neutrons, like the name suggests, are neutral. So neutrons do not have a charge. If you pictured it kind of like a number line, neutrons would be at the 0 mark, right in the middle. So I always remember it because neutrons are neutral. Sometimes people get tripped up and they think, oh, N for neutron must mean N for negative. Don't do that. That is wrong. Neutrons are not negative, they're neutral. So neutrons are neutral charge. They're not positive, they're not negative, they're right in the middle, they're neutral. So if you wanted to like represent the amount of charge they have, you could think of it like a little 0. So the cool thing about the neutrons is that I mentioned earlier that the nucleus of the atom is basically what makes up its mass or its weight. So the atomic mass of an atom, how heavy an atom is made up of adding the protons and the neutrons together. If you put your protons and your neutrons together, you'll end up with how heavy your atom is. Remember that fact, because that's going to come into play a little bit later down the line. So our positive protons and our neutral neutrons are hanging out in the nucleus, and together they make up the atomic mass of our atom. So we've got our protons, we've got our neutrons hanging out together in the middle. What's left over? Our electrons. So our electrons are what are orbiting around the outside of the nucleus, the outer part of the atom. So the protons and neutrons are just kind of chilling and hanging out in the middle of the nucleus. The electrons are zooming around the outside. So our electrons are negatively charged. These are our negative charges in our atom. So the protons are positive. The electrons are their opposites. They are negative. So the way that I try and remember this is that electrons, you might sort of think about the name, it sounds a lot like electricity, right? That's because electricity comes from electrons. When you make an electric circuit, it's the electrons that are moving around and providing the charge. And so if you get shocked with electricity, you are not going to have a good experience. You're going to have a bad, or one might even say a negative experience. So electrons are negative. They are negatively charged. Little minuses is how you could think about them. So we have our plus protons, our 0 neutrons, and our minus electrons. Electricity has a negative effect on people. Electrons are negatively charged. I already mentioned that atoms are super duper incredibly small. So protons and neutrons obviously are very small as well. Electrons are even more incredibly tiny and small. In fact, they are so small and light that they're not even counted for the mass of the atom. So they're so tiny, they really don't weigh into whether or not, or how heavy this atom is, right? If you're going to like be weighed on the scale at the doctor's office, the electrons are basically the equivalent of like whether or not you have an HEB receipt in your pocket at the time, right? Sure, technically it adds on some mass, but it's not really enough to be detected or noticed on the scale. So electrons are so small that they're not even counted in terms of the weight of the atom. So we have our negative electrons that are zooming all around the outside, and we have our positive protons and our neutral neutrons that are clumped together in the nucleus of the atom. And our protons and neutrons together make up the weight. Electrons don't really count because they're so tiny and small. All right. Anybody have any questions so far on atoms or the three different particles that make up atoms? Protons, neutrons, electrons.
No, sir.
All right. Sounds like everybody's doing pretty happy so far.
Is this
So
something
that's
like
good.
math? Hello?
Yeah, I hear you, Krita. Do you have a question?
Is this I'm curious because is this something like math? It has to do with math? Like
Not directly right now. We are gonna do a teeny tiny bit of math a little bit later on. So this is gonna come into play with numbers in a little bit, but just like super duper basic types of numbers.
okay. Because I had a lesson that I was starting on that was talking about this, and it was wanting to know the different things and the difference in between them, and
Oh.
how many it was between the neutrons and stuff.
Well, that is actually exactly what we are just about to be getting into. Good question. Way to think ahead. All right, so like Krita was just alluding to there, yes, we have these three different types of particles in our atoms, but they happen in all sorts of different amounts. All our atoms have different numbers of protons, neutrons, and electrons in them. Luckily, if you know the tricks, it's pretty easy to figure out how many protons, how many electrons, and how many neutrons are in each atom. And it's all thanks to our friend, the periodic table. So you may remember the first thing I showed you in this notes, that big table of all the elements. Each element had its own little box. On that original chart, the boxes were really small and squished together, so they could only fit a couple information on there. But on most periodic tables, like if you ever Google one, or I'll actually post like an expanded version of the periodic table in the Google Classroom after our notes today. Most periodic tables, each little box of the atom. Ooh, Gerson's making some guesses. We'll get there, Gerson, don't worry. Each little box of the atom contains 4 pieces of information, 2 words and 2 numbers. So each periodic table box has the name of the atom written out. So in this case, krypton is the atom that we are looking at. It also has the symbol of the atom. So a lot of times when scientists, especially chemists, are dealing with atoms and molecules and stuff like that, we don't want to have to write out krypton every single time we're talking about krypton atoms, because there might be 10 or 15 krypton atoms in the molecule we're studying. Instead, we can just write them using their little symbol here, Kr. So all scientists know that Kr is the symbol for krypton, just like C is the symbol for carbon, or Al is the symbol for aluminum. Zn is the symbol for zinc. Each atom on the periodic table has a 1 to 2 letter chemical symbol that's just used just as a nice shorthand way of writing it out. So that's our 2 words that are represented here. We also have 2 numbers. We have a smaller number, usually at the top of the periodic table in the center or in the corner. and a larger number, usually at the bottom of the periodic table, again, either in the center or in a corner. This top number is called the atomic number, and this bottom number is called the atomic mass, sometimes also referred to as the atomic weight. It tells us approximately how heavy that an atom is. So each one of these numbers can tell us something not just about the identity of this atom, but also, if you know what to look for, they can tell you about how many protons, neutrons, and electrons are in an atom of that particular type. So, how do you figure that out? How do you read the information in this box right here? Well, let's start with the atomic number up here at the top. So the atomic number tells us how many protons are in this atom. So our atomic number and the proton number are the same thing. Each atom has a different number of protons in it. That is the main way that scientists tell the atoms apart, and that's how they are organized on the periodic table. They're organized from the atom that has one proton, which is hydrogen, way up in the top right, to the atom that has 119 protons, which is some like unoctanium or something like that, way down in the bottom right. So however many protons that an atom has, that is its atomic number, and that is how scientists tell it apart from other atoms. So in this case, krypton has an atomic number of 36, which means there are 36 protons in one atom of krypton. All right, so each krypton atom has 36 protons in it. And krypton is the only atom with 36 protons. No other atoms have this number. All right, so
I have a question.
Yeah, go for it.
Is it like that with every element? Do they all have like just one element has that number and nobody else shares that number?
Exactly. Every single element has a different atomic number and nobody else shares it. So like, oh, I'm gonna zoom backwards really quick. Here's our kind of squished periodic table. Each of these numbers on here is the atomic number. So you can see we start with 1 and then jump over to 2. And the second row goes from 3, 4 up to 10. And then the third row starts 11, 12, 13 to 18. And the fourth row, 19, 20, 30, 36. Here's our krypton buddy right here. And
so everyone has its own number.
30s to 40s to 50s to 60s to 70s to 80s, 90s, all the way up to, I think the largest one they've discovered is somewhere around like 114, 115. Each one has its own number, and each one has a different number of protons. If you're looking at an atom that has 8 protons, it has to be an oxygen atom. If you are looking at an atom with 30 protons, it has to be a zinc atom. No other atoms share that atomic number. So that's pretty nice and easy. If you want to know how many protons an atom has, just look at that atomic number at the top, that smaller number up here. So that's pretty straightforward. Atomic number and proton number, same number, same amount, same thing. All right, moving on to our bottom number down here, the atomic mass. This tells us approximately how much does an atom weigh. Now, obviously, like I said, atoms are incredibly, incredibly tiny. Even with the most powerful microscopes that scientists have created so far, electron scanning microscopes, we have trouble seeing individual atoms. They're just so small. So obviously, we can't measure them on like a household scale, right? We can't put them in terms of like pounds and ounces or grams, because if you wanted to weigh an atom in pounds, it would be like a krypton atom weighs approximately 0.000000000000000000000000083 pounds. Nobody wants to deal with that. That's a huge number for such a tiny, tiny amount. Nobody wants all those zeros in there. So instead, scientists came up with a different way of measuring atoms called AMUs, atomic mass units. So krypton does not weigh 83 pounds or 83 ounces. It weighs 83 AMUs. One AMU is approximately the size or weight of one proton or neutron. So protons and neutrons are both about the same size, and they both weigh about 1 AMU. So our atomic weight of an atom just tells us how much does that atom weigh in AMUs. And it's a nice way to be able to distinguish between the different sizes of the atoms. Just like the atomic numbers, as you get further along in the periodic table, you get bigger and bigger and bigger atomic weights. So that's cool. It's nice to know what an atom weighs, apparently, in terms of its atomic weight. But what can this tell us about protons or neutrons or electrons? Well, we can use our knowledge of what makes up the atomic mass and this number down here to figure out the number of neutrons in an atom. And that works like this. We do have to do a very, very simple calculation in order to figure it out. We can't just look at the number and write down the number, but it's very easy. We've already figured out that the atomic number is protons, right? Our number of protons is the same as our atomic number. And you may remember that I mentioned this earlier. Our atomic weight, so the weight of our atom, is when we take the protons and the neutrons together, right? When I was talking about the different particles, I mentioned that electrons are so light that we don't really count them in the weight. So the weight is just the protons and the neutrons together in the nucleus. Add those guys up and you've got your atomic weight. So if we know how many protons we have with the atomic number, and we know that the protons and neutrons together gives us the weight, then if we take that atomic weight and take away the protons, take away how many protons are in there, minus that atomic number of protons, that will tell us how many neutrons that we have, right? If we have our protons and neutrons together is our weight, and then we take away the protons, we're left just with our neutrons. So if you take that bigger number, the atomic weight, and you subtract the smaller number, the atomic number, that will tell you how many neutrons that you have. So, for example, let's look at our good buddy krypton here. Krypton has an atomic number of 36, as we've already established, and an atomic weight of, I don't really like dealing with decimals, and I don't want you guys to have to deal with decimals either when you're doing these calculations. So it's totally fine and normal to round this atomic weight number to the nearest whole number. So like with krypton, it's 83.8. So I'm going to say that has an atomic weight of about 84. You can do this with any of your atoms. So like some atoms have an atomic weight of like 18.999. You can easily round that to 19. Some of them have a weight of like 12.001. You can easily round that down to 12. So whatever your atomic weight is, the reason why it has this decimal is that comes from scientists taking like super precise measurements and calculations and stuff to figure out the exact weight. We're just trying to figure out how many neutrons there are. And the easiest way to do that is just to round this atomic weight to the nearest whole number. So if we have 36 protons, because that's our atomic number, we want to figure out the neutrons, which means we have to do the atomic mass, which is about 84, minus the atomic number of 36. So 84 with the mass minus 36 for the number gives us 48 neutrons. So one atom of krypton has 36 protons and 48 neutrons in it. Like I said, you do have to do a very tiny little bit of math in order to get to that neutron number, but all you have to do is round off your atomic weight and then do the atomic weight minus the atomic number. Big number minus small number gives you neutron number. Sometimes the most common mistake that I see is people look at the atomic weight and just assume that's the neutron number. That is wrong. Don't do that. It doesn't work that way. They also sometimes get weird with this math. They try to add the number and weight together or like divide them or find the average or something like that. Don't do that either. Don't make this harder than it has to be. You just have to do simple subtraction. Big number, small number is your neutrons.
I'm sorry, but that big number, do you have to add it to do it to the nearest number, or can you leave it the same?
It's better to do it to the nearest number, just because atoms, you can't really have 0.8 of a neutron in there. And so it's better to just round it to the nearest whole number and then do your subtraction.
So what if I had something that said 22880?
So like
Just
22 point, like 0.8.
Yeah.
If it's 0.8, you'd round up to 3 or 223.
Okay. Okay.
So
That's
if it's
all
like, no worries. So yeah, if your decimal is like 0.7 or 0.8 or 0.9, you can round it up to the nearest whole number. If it's like 0.01 or 0.1 or 0.2 or 0.3, you can round it down. If it's kind of in the middle-ish, usually the tipping point is 0.5. So if it's over 0.5, you'd round up, and if it's under 0.5, you'd round down. I don't think there are any atoms that are exactly something 0.500. And so hopefully that won't come up if that's what you were asking about, Gerson.
Yes.
I have a question.
Yeah.
This might sound stupid.
Nuh-uh.
So what if like you have the atomic weight and the neutrons, I'm sorry, and we're looking for the atomic number of it? Like say we have a question down the line. Do we just add it or like how do we go about that?
In that case, you would also subtract. And so if you had the atomic weight, so atomic weight is protons plus neutrons, right?
Mm-hmm.
Want to figure out what either one of these is, you would subtract the other one from the atomic weight. So the weight minus the protons is the neutrons, which is what we've been doing. But also the weight minus the neutrons gives you the protons, right? Because the protons and neutrons together give you the weight. So if you take away one, you'll be left over with the other one.
Okay, yes. I think I had trouble with that real big last time. So I was like, I need to ask that. Thank you.
Yep, no worries. There's at least no questions on the homework that are like that. There might be some like that on future assignments, but that's a good question, good thinking ahead. So yeah, the weight will always be the biggest number of your atom. So your protons and your neutrons will always be smaller numbers than your atomic weight. So if you're trying to figure something out and you end up with a number that's bigger than the weight, you've done something wrong. So remember, if you want to figure out one of those, you're always going to be subtracting. The atomic weight minus one of them will give you the other one. Similarly, if you're given the number of protons and the number of neutrons and asked to calculate the weight, you just have to add those two together. All right, good questions so far. Anybody else have any questions about figuring out our numbers of protons or our numbers of neutrons?
No, sir.
All right, awesome. Cool. All right, so let me think. We've done protons, the atomic number. We've done weight, which is the neutrons, which is the weight minus protons. So that leaves, electrons. So if we want to figure out how many electrons are in our atoms, luckily, it is also very easy. The atoms that we are going to be dealing with in this particular class are called neutral atoms. And what that means is that they have a balance of positive and negative charges. Their positive charges and their negative charges exactly equal one another and cancel each other out. What that means for our electrons is that our number of protons and our number of electrons will always be the same with our neutral atoms that we have. So we'll always have the same number of protons and electrons. However many protons we have in this class, that's how many electrons that our atom has. I will say that's not always the case. There are lots of cases where atoms will have more electrons or less electrons, and that'll give them a negative charge or a positive charge. But we're not going to worry about those cases in this class. We're going to focus on neutral atoms. And so our atoms are always going to have an equal number of protons and electrons because we need those positive protons to cancel out those negative electrons. So you can end up at the end of the day with no charge on our atoms, a total amount of charge of 0. So in order for our positive charges and our negative charges to equal out, there have to be the same number of them. So the simplest example of this out there is hydrogen. Hydrogen is the very first atom on the periodic table, way up there in the top left corner, all on its own. Hydrogen has 1 proton, which means that in order to be balanced, hydrogen needs to have 1 electron. So in our hydrogen guy here, the positive proton and the negative electron are balanced out with each other. So we have a nice neutral atom. So that atomic number not only tells you how many protons that you have, but in our class, in dealing with neutral atoms, it also tells you how many electrons that the atom will have. So a really handy dandy number up there in that top side that atomic number. So let's look at a basic example of carbon right here. Carbon, the element, has a symbol of C. It has an atomic number of 6 and an atomic weight of 12.01, which pretty easily rounds to just 12. So, how many electrons does carbon have? Feel free to answer either in the chat or on the mic. How many electrons are in carbon?
Was it 6?
6. Correct. And Giovanni, how could you tell that there are 6 electrons in carbon?
Because they are neutral to the protons, so they pretty much are the same thing.
And the bottom number.
Exactly. So carbon has 6 protons, and we know that because the atomic number is 6. So if our atomic number is 6, our protons are 6. And if we have 6 protons, we have to have 6 electrons. So this number right here is very helpful, and it tells us how many protons and how many electrons that we have. So that is how we can use this number to figure out our electrons. What about, let's do a really quick review here. How many neutrons does carbon have?
Six.
6 is correct, Larissa. And how did you figure out that carbon has 6 neutrons?
I subtract the 6 from the atomic number from the atomic weight.
Mm-hmm. Exactly. Atomic weight is basically 12, and our atomic number is 6. So 12 minus 6 gives us 6 neutrons. So carbon is a cool little element. Not only is it super important for life on Earth, most of the stuff that we eat and the stuff that our cells are made of is made out of carbon. But also, like a lot of the smaller elements, carbon has the same number of protons, neutrons, and electrons. So the first 7 or 8 atoms, I think, have this happen where they have the same number of all 3 types of particles. As the atoms get bigger than that, though, they tend to get more and more and more neutrons. So like we saw earlier, krypton is a pretty big atom. It has 36 protons. And so it has way more, it has more neutrons. Its numbers are not equal right here. So the really small atoms do have all the stuff kind of equal out, but as you get bigger, you tend to get more and more neutrons. Oh, speaking of krypton, now that we're back on this page and we haven't talked about this guy before, how many electrons are in krypton?
Six.
36.
Yeah, 36. Exactly. So our atomic number up here, 36, tells us not only how many protons that we have, but also how many electrons that we have. All right, very, very, very nice. So does anybody have any more questions, anything that you want to ask about protons, neutrons, electrons, or how to find their numbers?
No, sir. No, sir.
All right, cool, cool, cool. So hopefully this all feels pretty fresh and feels like it makes sense to you. because this is mostly what your assignment for today is based around. So let's see here. Our Tuesday assignment is all about figuring out protons, neutrons, and electrons. So on this assignment, we have 6 different atoms that I want you guys to look at. We have fluorine, which has an atomic number of 9 and an atomic weight of about 19. We have scandium, which has an atomic number of 21 and an atomic weight of about 45. We have platinum, which has an atomic number of 78 and an atomic weight of about 195. We have radon, which has an atomic number of 86 and an atomic weight of about 222. We have uranium, which has an atomic number of 92 and an atomic weight of about 238. And borium, one of the largest elements that scientists have discovered so far, which has an atomic number of 107 and an atomic weight of 264. Borium is so big and so kind of unstable that scientists have a hard time exactly measuring its weight, which is why it has this kind of estimated weight in the brackets right here, why it looks a little bit different. But regardless, its weight is 264, and its number is 107. So for each one of these atoms, I want you to tell me how many protons, how many neutrons, and how many electrons are in each atom. So on our Google form right here, which I know is what most people like to use, make sure that you answer each one of these 3 particles in the little answer box. You only have the one answer box for the 3 particles. So your answer should look something like, and obviously this is not going to be right, like 1 proton, 2 neutrons, 1 electron. But make sure each particle is listed out. You can also, if you want, do it a kind of condensed way and do like 1 P 2 N.
Okay, see like this one right here where it says 18.998. So put that at 19?
Exactly.
Okay. Okay.
Exactly. So yeah, if you wanted to write out proton, neutron, electron, or just write like shorthand 1p, 2n, 1e, that works for me as well, as long as you have all 3 particles and each number is labeled, so I know which one is which. You can also, if you want, do it on the Google Doc version, which is set up a little bit more easy to put in your answers. This one already has the protons, neutrons, and electrons listed out. And so all you'd have to do is like 1 proton, 2 neutrons, 1 electron for that one. Whichever way that you do it, just make sure that you have all 3 particles, proton, neutron, electron, and a number for each one. So those 6 atoms are your daily assignment for today. And then the daily assignment that's going to be posted tomorrow is a really simple, basic overview of some of the main stuff that we talked about here today. And so it has a little bit of a review of what protons, neutrons, and electrons are. It then has this little box from the periodic table right here. And I want you to use this to tell me what is the name of this atom, what's the chemical symbol of this atom, what is the atomic number, and what is the mass number. You can give me the whole mass number or the rounded mass number. Either one is fine by me. Then has a little overview of protons and electrons. The one thing that people get wrong on this worksheet all the time is that they do not read number 5 carefully. Number 5 asks how many protons and how many electrons are in helium. So there should be 2 different answers on number 5. Even if it's the same number, I want you to tell me this many protons, this many electrons. So make sure tomorrow when you're doing this, you read number 5 carefully and put down 2 answers in this one. And finally, number 6 asks about the number of neutrons. Again, very basic, very simple example. Just to kind of review the basic information about protons, neutrons, electrons before we start talking about them in a little bit more detail on Thursday. So that will be posted early tomorrow morning. So you have all day tomorrow to work on that guy. All right. Anybody have any more questions about protons, neutrons, electrons, or the daily assignments for today or tomorrow?
No, thank you.
No, sir.
No, sir. No questions.
No, sir.
All right. Awesome. The one last thing that I wanted to bring up before we wrap it up here this evening is me and some of the other teachers have noticed that we're seeing some attendance dips on our asynchronous days, meaning the days that we don't have class like this. So for us, that would be on Mondays and Wednesdays. For the most part, I recognize a lot of you guys have been showing up and doing those daily assignments on those days. So definitely keep up the good work. But just kind of a midterm reminder here as we start to get into the middle period of term 5, make sure that on Mondays and Wednesdays, even though we don't have class, you're still checking in on Google Classroom and doing those daily assignments. That's the best way to get counted for your attendance on that day. And the easiest way that I found that people mess up and end up with too many absences at the end of the year is by consistently forgetting to do those attendance checks on Mondays and Wednesdays. Mainly, honestly, the main place that we're seeing it is during the day school. There's a lot of people that are not logging on Fridays and doing their Friday homework. Luckily, night school, we don't have any Friday classes. So you just have to keep up with your Monday and Wednesday classes. If you are taking any day school classes during the afternoon or the morning, please do make sure that you're coming back to that class on Friday as well, either for class or to do the daily assignment on that day. Because we want everybody to make it to the end of the term and not have to worry about their absences, keeping them from getting IPC credit or math credit or whatever class that you're in. So as long as you're checking in on Monday and Wednesday and doing a daily assignment on that day, then you will be in good shape by the time the end of the term rolls around. If you ever want to keep an eye on your absences or double check me and make sure I'm doing my job and counting your absences and attendance correctly, you can always look on Skyward. So Skyward not only has a place where you can check on your grades, but it also has a way for you to check on your absences as well. And not only see how many absences you have in a class, but also make sure that your teacher is putting in your absent days and your present days correctly. Because sometimes we're humans, we still make mistakes. We accidentally forget to put something in. And we always appreciate it when you guys let us know, hey, I was here on this day, I did this assignment, but you still have me marked as absent. We're more than happy to go in and change it back to present if we need to. Yeah, Star, question.
Yes, I went on the Skyward, and it says that I was absent yesterday, but I always check in.
Was it
So if
for
you could just check that for me.
yesterday or for today?
No, it was yesterday. It said that I was absent for your class, but I always go ahead and do whatever you ask me to check in.
Have you checked again today?
I haven't checked recently.
So that's a good point, actually. Thank you for bringing that up. So one thing, so that can happen where you check and it's like, wait, it says absent, but I already did my thing for today. If you're checking on that day, so like today is Tuesday. If you checked earlier today, or if you go and check right now before class is over, it'll say that you're absent for today. That's because Skyward automatically lists all the students at the Excel Center as absent at the very beginning of the day, 12:01 a.m. Everybody goes in the absent column. And then as teachers, we have to go in when you turn in your work and change that over to present. So there's a button I click where I say present, or we have synchronous, meaning you came to class, or asynchronous, meaning you completed an assignment. So until the teacher does that on that day, it'll show up as absent on Skyward. So I'm guessing, Star, what probably happened, because some of the attendance I didn't get to until later in the evening. So you probably checked in like the afternoon and early evening, and it said you're absent on Monday. But then Monday night, I went in and changed it to present. Because it looks like I have your name written down over here, and I have it checked off, meaning that I checked you off on the roster as well. So on the day that you're, like if you're checking, if it's Monday and you're checking for Monday, or it's Thursday and you're checking for Thursday, it might say absent until the end of the day whenever your teacher gets around to putting in their attendance. Sometimes it might happen in the afternoon or the evening. It just depends on the teacher and the day. So if you're ever worried about that, give it until the next day and then check like Wednesday's attendance on Thursday, and then you'll be able to see if your teacher ever did go in and change it back to present.
Okay, thank you.
All right, no problem. Good question about that. So yeah, like everybody on this call right now, I haven't done any sort of attendance for IPC night class yet. So everybody on this call right now is marked as absent in Skyward at the moment. In a couple minutes after we finish up here, I'll go through, check all my classrooms, and then go into Skyward and update everybody's attendance for the day. So that's kind of how Skyward works, and that's how sometimes it might look like you're marked as absent for the day, when in reality it just means that your teacher did not get around to marking you present. If you ever do find an actual mistake, just like Star thought that she did, please feel free to reach out to me. Send me an email, send me a text, and I'm more than happy to go in and check and either let you know, oh, I'm sorry, you're right, I missed it, let me go put it in, or I'm sorry, unfortunately, I don't have any work turned in from you on that day, so you're going to be counted as absent. Always feel free to check in with me about any of your absences or grades or anything like that, and I'm more than happy to check on that stuff for you guys.